Okay, so my video cut off there. But what I was starting to say is that when you have -1 plus or minus the square root of -23 over 2, you have no real solution because this is a complex number. So what I want us to do now is to check this graphically. We need to plug in the left-hand side for y1 and the right-hand side for y2. So what I want you to do is pause this video, plug that into your calculator, and see that those two lines, or those two functions, never intersect. So I just graphed those two. I put the functions into my y equals, as so. I set my window from 0 to 40 for x and 0 to 10 for y. And when I did that, I got a graph that looks like this. So what's really important for us to note is that the distance between the two functions is getting larger as x gets larger. So that's how I know that these two functions are never going to intersect. And if they never intersect, that means we have no real solutions. So I'm just going to make a little note here that the graphs never intersect. Now, we've already gotten some good practice at this. It says sometimes we are unable to solve analytically, even though there are real solutions. This is when we need to approximate the solutions of the equation using graphical means. In other words, plug them into our equation, or into our calculator, and see when they intersect. So we are going to plug in y1 equals 2.3 times the natural log of x plus 10.7. And y2 equals 10 e to negative 0.7 x squared. Now, I want you to take note. The reason why this cannot be solved analytically is because on one side we have a logarithm, and on the other side we have its inverse, an exponential function. So if I try to undo the logarithm, I won't be able to undo the exponential. So we would be in this constant struggle of trying to undo one and not being able to undo the other. So graphically is the only way that we can solve this with our current algebraic knowledge. So if we wanted to plug those two things in, we're going to have an x min of 0, an x max of 10, a y min of 0, and a y max of 20. So go ahead and pause this, plug this into your calculator, and sketch a graph. Now your graph does not have to be beautiful, it just has to be approximate. So let's go ahead and do that right now. Okay, so here's my approximate graph. It's not beautiful, as you can see. However, I do show the two separate graphs along with their intersection point that I found by doing second trace intersect. Now, we are looking for x values. So why it is interesting that they both share 5.9714 in common, the 2.713 is what we care about. So x is approximately equal to 2.713. Because remember, all we can get is an approximate solution when we're graphing. Okay, so this is the end of our section 5.5 notes. Let me give you your homework from this section. Your homework is on page 363, numbers 7, 25, 31, 39, 49, and 67. So I did make this shorter than our previous section's homework, just because I know that you're not seeing me. Please feel free to email me when you have questions. My email address is Jamie Lynn Shepherd. Oops, that's a D. at gmail.com. And I love when you send me a picture of the problem. Even if you haven't started the problem yet because you don't know how to start it, it is still a lot easier for me to answer you if you send a picture of the problem, because that way If I'm out and about and I don't have my homework or my book close to me, which does happen, I can answer the question just by looking at it. So pictures are appreciated and they make me give you a quicker response. Okay, so this concludes 5.5. I'll see you soon for section 5.6.